So last time we were looking at in 2 dimensions. So we did the 2D derivation. It does also work for the 3-dimensional problem. We were looking at a position vector parameterized by R of t was f of ti plus g of tj, where x is the f of t function and y is the g of t function. And we were able to show that if I take the derivative of the position vector, I end up with dr dt, and that is what we see here. So now I can give a definition. And my definition is the vector function vector valued function R of t equal to f of ti plus y of t.
This is the last section on the exam, right?
This is the last section on the exam.
Okay.
Yes. Is differentiable at t equal to t naught if f and g are differentiable at t equal to t naught. Also, R of t is differentiable if it is differentiable at every point of its domain. Okay, so moreover, dr dt is equal to f of ti plus g, f prime of ti plus g prime of t j. Definition. The curve traced by R is smooth if dr dt, and that vector is over the wrong thing, if dr dt is continuous and never zero. So it can never be the zero vector. In other words, f prime of t and g prime of t are never both 0 at the same time. Okay. All right. So now, given a curve, r of t, dr dt is tangent to the curve. Okay. So that picture I had last time. I don't know what this is doing. So this is my vector r, and then this. So here, the red curve, okay, let me do that again. I don't like that. The red curve is r of t. And then that is r prime of t. Okay. So definition. The tangent line to the curve at a point, I'm sorry, yeah, the tangent line to the curve r of t at a point r of t naught equal to, no, I don't want that. I want just the point f x y equal to f of t naught g of t naught. So there's a tangent line to the curve. Is the line through the point f of t naught g of t naught and parallel to the r dt at t naught. And note a smooth curve has no sharp edges no sharp corners or cusps. Okay, so for example, what's going on? Why is this doing this to me? I don't know what's wrong with my OneNote that it does this, but it drives me completely bonkers. It just, so if R looks like this, it is not smooth. Okay. Now, definition, we can talk about a piecewise smooth curve though. So that is piecewise smooth. It's smooth on this piece and it's smooth. So from here to here, it's smooth. And from here to here, it's smooth. So I can talk about a piecewise smooth curve. All right, is made up of a finite number of smooth curves. Okay. All right, so now we're going to start defining some things. All right. Definitions. So let me. These are more than one. So we want to let R of t be a position vector of a particle moving along a smooth curve in space. Okay. Then first thing we want to define is our velocity vector. So the velocity is the derivative of the position. So V of t equal to dr dt is the velocity vector. And it is equal to the derivative derivate. Okay. 2, speed, that's new of t. It is not a vector. It is the length of the velocity vector. Okay. This is the speed and it is equal to the magnitude of the velocity vector. Okay. So nu is equal to the square root of f prime of t squared plus g prime of t squared. Okay. Acceleration. A of t. It is the derivative of the velocity vector, and it is the second derivative of the position vector. So this is the acceleration. It is equal to the derivative of the velocity vector, and it is equal to the second derivative of the position vector. Okay. And then number 4, the vector v over the length of v. This is the direction of motion. All right, at a given time t. And it is a unit vector. Okay. Quick, easy example. Easy, 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 easy. So r of t is equal to 3 cosine ti plus 3 sine t, 4 sine tj. Okay, this particle is traveling in an ellipse. Okay. The reason why I know this is because this is an ellipse. Because x of t is 3 cosine t. And so therefore I get that the cosine of t is x over 3 and y of t is 4 sine t. So that says the sine of t is y over 4 and the cosine squared cosine squared t plus sine squared t is 1. And that says that x over 3 squared plus y over 4 squared is 1, and that is x squared over 9 plus y squared over 16 is 1. So that's how I get an ellipse. Okay. So we know R of t, so let's just write R of t is 3 cosine ti plus 4 sine tj. V of t is negative 3 cosine ti. No, it's not. It's negative 3 sine ti plus 4 cosine tj. And the acceleration is negative 3 cosine ti minus 4 sine tj. Okay. Find velocity at pi over 4, acceleration at pi over 4, and the speed. That does not look like a nu. And the speed at pi over 4. Okay. So we got all of those. And so now we get R at pi over 4 is 3 times the cosine of pi over 4 I plus 4 times the sine of pi over 4j. So that is the vector 3, the root of 2 over 2, I plus 3, no, plus 4, the root of 2 over 2j. So that's that. V of pi over 4 is negative 3, the sine of pi over 4i, plus 4, the cosine of pi over 4j. So that is negative 3, the root of 2 over 2i, plus 4, root of 2 over 2j. May as well find nu while, well, yeah, let's find nu while we're right here. So nu of pi over 4 is to take the square root of 3, the root of 2 over 2i, well, that's squared, plus 4, the root of 2 over 2j. Well, I'm sorry, that's squared. So that actually becomes the square root of 9/2 plus 8. And that is 5 root of 2 over 2. Okay, so that's new. And then a of pi over 4 is going to be negative 3 the root of 2 over 2i minus 4 the root of 2 over 2j. Okay, now here's a question. When is the velocity perpendicular to the acceleration? Okay. That's not my question. My question is, when is the velocity perpendicular to the acceleration? And the answer is when v dot a is 0. So if I take v dot a, I get minus 3 sine t plus 4 cosine t. Nope, minus 3 sine t. Or cosine t. And I'm dotting that with minus 3 cosine t minus 4 sine t. Okay, so that says that negative, oh, nothing's negative. That says 9 times the cosine of t times the sine of t minus 14, 16 times the cosine of t times the sine of t is equal to 0. And that says that negative 5, the cosine of t times the sine of t is equal to 0. And I'm going to divide by negative 5 and multiply by 2. So I'm going to write this as 2 the cosine of t times the sine of t is equal to 0. So this is 2. This is the sine of 2t. So the sine of 2t is equal to 0. So that says 2t is a multiple of pi. So that says t is n pi over 2. Okay. All right. Do some differentiation rules. There's several. Okay. The first is the constant function rule. Okay, and that says the derivative with respect to t of a vector of constants is 0. Okay, so if C looks like C1 I plus C2J plus C3K, and I take the derivative, all of those derivatives of constants are 0. So I will just get 0. And that is actually the 0 vector. Okay. That is the 0 vector. Okay. So now I want to let U and V be differentiable vector functions. And of T. And I want to let F be a differentiable function. F and R be differentiable. So it is a scalar valued function. So U and V are vector valued functions and F is a scalar valued function. Okay. All right, so scalar multiplication. All right. All right, so I can take, oh, C has to also be a constant. C is and C is just a real number. Okay, so the derivative with respect to T of C times a vector valued function is the same as if I took C and multiplied by the derivative of the vector valued function. And the derivative with respect to T. So now I'm going to take F of T and I'm going to multiply it by the vector valued function U of T. So this is the same as the product rule. It is the derivative of F with respect to T times U of T plus F of T times the derivative of U with respect to T. Okay. Okay, so for the sum rule, this is simple. I'm going to call it the sum rule and the difference rule. I'm going to put both of them in here together. Doesn't make sense to do two rules when I can do okay. So that is the derivative with respect to T of the vector U plus or minus the vector V That is the same as doing the derivative of the vector u with respect to t plus or minus the derivative of the vector v with respect to t. Then we have the dot product rule. Okay, and that is the derivative with respect to t of u dotted with v, and this is the derivative of u with respect to t dotted with v plus u dotted with the derivative of v with respect to t. Okay. Next, we have the chain rule. And the chain rule says R is a function of t, and t is a function of s. Then dr df, this is a big deal. Is dr dt times dt ds. Okay. And then the last, which is the hardest one, it's not really hard actually, now that I think about it. It seemed hard when years ago, the cross product rule. And that is the derivative with respect to t of u cross v, and that is equal to the derivative of u with respect to t cross v plus u cross dv dt. Okay. I just want to go back to one thing and give this a name. I'm going to call this the unit tangent vector. So right here, I'm just going to slide that in. That t equal to v over the length of v is the unit tangent vector. Okay, Let's do some examples. So let R of t equal 3 e to the ti plus 4 down t to the 1/2 power j plus sine tk. Find R let me go back and make this t to the 5/2. Okay. So find R at, I still don't want to find R at 0. That's boring. Gonna go back and leave it what it was. And find R at pi over R at pi. V at pi, T at pi, A at pi, R prime at pi. That's not what I meant. That's easy. I don't need to find R prime at pi. That's all I want. Okay, so R at pi that is 3 e to the pi I plus 4 the square root of pi j, and that's it. Okay. V at t is equal to R prime of t. So that is 3 e to the t I plus 2 t to the negative 1/2 j plus cosine of t k. So therefore V at pi is what? What is V at pi? Hello? Okay. I guess I am teaching to myself. So this is going to be 3 e to the pi 2 over the square root of pi negative 1. A at t is going to be v prime at t. And that's going to be 3e to the ti minus t to the negative 3/2 j minus cosine t minus sine t. Okay. Okay. So a at pi is going to be 3e to the pi minus 1 over the square root of pi. Oh, no, no, no. I'm just going to write it as minus pi to the negative 3/2 power 0. Okay. I need to find new, I think I said. Nope, I said okay. Oh, I asked to find the unit tangent. So that's v over the length of v. So therefore, let's find, we already found v. So the length of v squared is 3, no, it's not. Yes, it is. 3e to the pi squared plus 2 over the square root of pi squared plus negative 1 squared. And that is 9e to the 2 pi plus 4 over pi plus 1. So therefore the unit tangent, which is not always nice, as you can see, is the vector. Where's the unit tangent? It is 3e to the pi I plus 2 over the square root of pi j minus k divided by the square root of 9e to the 2 pi plus 2 over pi plus 1. Okay. All right. Now, similarly, we can compute the integral of r of t dt. So the integral of r of t dt is the integral of f of ti plus g of tj plus h of tk dt. And when I integrate this, I'm going to get f of t plus a constant c1 I plus g of t plus a constant c2j plus h of t plus a constant c3k. Where f prime of t is little f of t, g prime of t is little g of t, and h prime of t is little h of t. So in other words, the integral of r of t dt looks like f of ti plus g of tj plus h of tk plus a vector c where c is equal to c1, c2, c3. Okay. So given, here's a problem, an example. Given r prime of t is equal to the sine of ti plus e to the tk, I'm sorry, e to the tj plus the log of t. I don't want that to be the log of t. I want that to be 1 over t. And r r of pi is the vector 1, 1, 1. Find r of t. Okay, well, I know r prime of t, so I can integrate it to find r. So r of t is the integral of r prime of t dt. And when I integrate that, I'm going to get the integral of the sine is minus the cosine. So I'm going to get minus the cosine of t plus the constant C1 I plus e to the t plus a constant C2 j plus the natural log of the absolute value of t plus a constant k. All right. So r of pi is equal to negative cosine of pi plus C1 I plus e to the pi plus C2 j plus the natural log of pi plus C3 k. But that also has to equal I plus j plus k. So that implies that negative cosine of pi, that's just 1. So 1 plus C1 is equal to 1. So C1 is 0. E to the pi plus C2 is equal to 1. So C2 is equal to 1 minus e to the pi. And the natural log of pi plus C3 is equal to 1. So that says that C3 is equal to 1 minus the natural log of pi. So now I'm done. So R of t is equal to negative cosine of ti plus e to the t plus 1 minus e to the pi j plus the log, nope, that's right, plus the log of t minus the log, plus 1 minus the log j. Okay, any questions? Okay. I am going to stop here today.